I'm David Closter, and this is my colleague Katie Chapman, and we're going to be the ones talking today and leading you through the hands-on portion as well. We're with Cyberinfrastructure for Digital Humanities and Creative Activities, CyberDH for short, because that is a mouthful, and that is part of Research Technologies, which is also part of UITS, which is all here at Indiana University. So there's all those different levels to go through here. If you have not yet, go ahead and create a Carbonate account. The link to the knowledge base that will explain that to you in more detail is right there. But if you already have, great. I know somebody mentioned that they had and it hadn't been approved. So it takes about 20 minutes, we found. It can take as long as a half an hour and apparently an hour. So the sooner you do that, the better. If you want to access the slides for even after this presentation, just so you have them, we do have them up so you can go back through them. Or if you just want to look at them on your laptop as we go. Our schedule for this is the first of 3 workshops that we're doing, and they will all be in the same place, in the same location, same time, on the same day, Fridays from 12 to 1. So today's text analysis with Jupyter Notebooks. Next Friday is going to be topic modeling with Jupyter Notebooks. And then finally on the 28th, sentiment analysis with Jupyter Notebooks. So if you're interested in any of those, feel free to come. A brief outline of what we're going to be going over today. So we're going to pregame, which is we're going to get you guys set up on Research Desktop and go through that process. Then we're going to talk a little about what text analysis actually is and what it's used for. And then we're going to make word cloud. And then we're going to make a stacked area graph using Jupyter Notebooks on Research Desktop. So. All right. So Research Desktop, there's 2 ways to access it. You can either do it through ThinLink, or you can now just go to red.uits.iu.edu in your favorite browser. And this is the way we're going to do it today, because otherwise there's a whole nother setup process we'd have to go through on ThinLink. But you can do it whichever way is most comfortable for you after. The nice thing about Research Desktop is it uses the supercomputer Carbonate, which is why you need an account. So this is great if you have something like we've used where we have about 3 million tweets and you don't want to fry your laptop, you can run it on here. It does it a lot faster. And again, you don't tax your own system. And the other nice thing is it already has Jupyter Notebooks installed. So you don't have to go through that either. So a little about Jupyter Notebooks. They can use multiple programming languages. Initially, they were IPython notebooks, so it was just Python, but they have expanded a lot over the years. And R is another language, which I know people that do text analysis and digital humanities, that's usually the other programming language we usually use, one or the other or both. But there's other ones besides that. It allows for detailed annotation of the code. So you can see over here, there's a nice long list explaining some of these packages over here and over here. So this makes it really good for pedagogical tool, as a pedagogical tool for beginners, but it can also be used for people who are really experienced coders. We have people in our group that actually have PhDs in computer science that use the Jupyter Notebooks to do their coding. So. And then we are going to be using Python. All of our notebooks are in Python. And so a little bit about Python. It was created by Guido van Rossum and first released in 1991. And it's named after Monty Python, the show, not the snake, even though that is the emblem that they use and you see it everywhere. The comic group, sorry, the comic group. It's named after Monty Python. The comic group. It's beginner friendly. It reads almost like English in a lot of places. So if you've never coded before, I always recommend Python as a good beginning language to learn for that reason, because you can come in and kind of look at it and have some idea of what some of the code is doing. It's versatile. It's used for all sorts of things. We're going to do it with text analysis. It's used for data mining, for visualization. It's used for machine learning. It's actually really popular for that. And it makes use of packages, or modules is another term for them. So basically pre-created bits of code and functions and stuff like that that you can use and pull in, so you're not having to recreate the wheel and come up with some of these things yourself. So, and we'll talk about that a little bit later too. So now I'm going to pass it off to Katie.
All right, so for folks who are going to follow along, we're just going to go ahead and make sure that everyone can access RED and is ready to go for the hands-on part of the workshop later. All right, so I know you were set up with Carbonates. Nope. Have you requested it already? Okay. And Max, you haven't gotten your confirmation yet? Okay. Yeah, that's one of the great things about running it in RED. Yeah.
Technically, if you save it in your home directory, they might still work. So you can try it.
Yeah. Okay. We're going to walk through setting it up, but since only one of the people following can access it right now, okay, I'll just go over the generalities then. All right, and so as David mentioned, we now have a browser option for Research Desktop, which makes it very easy to access because you can do it from any browser, and which also means you can use it from a tablet now because you can log in from that, which was not possible with the previous CARS desktop. And so you log in with your normal IU credentials and do duo authentication, and then you will get access to the interface, and you'll be in the RED environment, which will look just like a typical desktop. It runs on a Linux system, and that's running on Carbonate itself. It has lots of pre-installed software, including Jupyter Notebooks. So it's just very easy to get up and going on this. So when you are able to get into RED and log in, you will access the repository where all of the code and the data is for the notebooks, which I know, Max, you were going to try and run. So if you are in Research Desktop, open Firefox within RED. Max, otherwise you can go to Firefox or your favorite browser. We'll navigate to this link here, https://cyberdh/text-analysis. All right, did everyone get that link? All right. So once we're in the repository, you'll see that's unusual. There we go. It snapped. That's all we had to do. And so you'll see, how many of y'all are familiar with GitHub? Yeah, some. Okay, so a bit of a mix. So what we're going to do right now is just download the entire repository. And so on clone or download, click the arrow and then choose download zip. After you do that, it will say downloading. It will keep saying that long after the file has actually already downloaded. So go to your download location after that. If you're within RED, it will ask you to save the file automatically. And sometimes it just saves it to your download folder. So it may pop up, choose save file, click OK. It may immediately ask you where to save it. And if so, save it in your home Carbonate directory. Otherwise, it will just automatically download it to downloads. And so you're going to open File Browser in Research Desktop, go to Downloads, and drag text analysis-master to your Carbonate home directory. And everything we do today will need to be saved in your home directory in Carbonate because that's where the paths and the notebooks are pointing to. Okay, so you can't copy between your machine and RED because they're actually two different machines. You're technically on two different computers right now. Sorry, so you do have to type that in manually, unless you, yeah. if that's easier, yeah.
But it's really hard to get used to that this is not just another like application on your computer. Like literally you're on like a remote computer. And so it doesn't know what's in the memory of the copy that you're trying to paste into that window because they're two separate systems.
Right.
Now you can't if you use the ThinLink client instead of the browser.
There are advanced options, which are there are nice KB articles about if you want to look at those. Yeah. All right. Have you been able to get to the repository yet? Okay, great. Yeah. So there, once everyone's got it downloaded, we'll move on to extracting. We just want to make sure we're all in the same place first. Are you set? Okay, great. Yeah, save file and click OK. It may automatically ask you where you want to save it. And if so, pick your home directory in Carbonate. If it doesn't prompt you to do that, then it's saved it automatically to your downloads folder and we'll drag it there. So if it didn't prompt you, go to your desktop and open File Browser and then click Downloads and you'll see the zip package here. And then you can just select it and drag it over to Carbonate. So before we can work with it, we do have to extract the files, which is the next step. Whether you saved it to your home directory or you've dragged it there, the zip package should now be in your home directory in Carbonate. Does everyone see it there? Yeah. No, no, it's fine. I just want to make sure we stay together and don't get. Yeah, to your home directory on Carbonate. All right, great. So now we're going to extract it. So find the file in your home directory, textAnalysisMaster.zip, and then click on that, double click and click extract. Right. Yeah. Did everyone get to the extract window yet? Okay, so once it's highlighted, click extract. It'll ask you where you want to save it and choose your home directory again, and it'll extract the files there. Excellent. Is anyone online? Okay, then I won't ask questions. All right, does everyone have the files extracted now? Awesome. All right. The next step, we're going to create a .modules file, and this is a file that the notebooks use to make sure that the correct version of Python is being used as we're going through. So we're going to make a new text document first. So in red, go to Applications, Utilities, then Text Editor to open your text files. You'll get a new blank text document.
This step is only for research desktop, so don't follow if you're trying to run it on your own system.
Yeah, and if you need someone to look at it with you, we can come over or. Okay. All right, once you have the text editor open, we're all gonna type this in and then save the file. So you want to say module unload Python. And then on a new line, module load anaconda / Python 3.6 / 4.3.1. We tried to make it big enough so that y'all could read that instead of having to type it from me talking.
Make sure you name it .modules. File.
Yeah.
Knows to look specifically for that file whenever you load it and read that and execute those commands. So.
Yeah, so when you click save, you'll name it .modules, make sure it's saving it in your home directory where we saved the other files, and then click save. You won't actually see it automatically if you go to your home directory because it's a hidden file because it has the dot as the first character. You think you got it? All right, awesome. All right, great. And so to make sure that this takes effect, we actually have to log out of Red and log back in. And so there are two options you'll see on your desktop. Disconnect thin link session and log out. Disconnect leaves your session running. And so if you're working on something, you're just gonna come back later, that's the one you wanna choose. In this case, we wanna log out and start a completely new session so that the settings in the .modules file will be there when it comes up for the new session. So just log out and log back in. And then David is going to talk to you about what text analysis is. Oh, right. Did everyone get to log back in yet? We're still working on it. What's it doing? Oh. Okay. All right. And the reason we have you make a file rather than just running in terminal these commands is so that whenever you come back to this and want to run these notebooks again, that file will be there when you need it. So you don't have to run those terminal commands every time. All right. Is everyone able to get Jupyter read back in? Then we'll launch the notebooks. All right. So you'll go to Applications, Analytics, and you'll see Jupyter Notebook is the first choice there. And so click on that. You'll see a terminal pop up and a little dialog box that says that Jupyter Notebooks will start soon. It can take a couple of seconds depending on the connection. The Wi-Fi in this room can sometimes be a little slow, so every now and then we notice things take a little longer in here. And then you will see a list of the notebooks that you have access to, and you'll be in Jupyter Notebooks within the red environment. And you can see, like here, you'll see Text Analysis Master, and those are the files we were working with later and during the hands-on portion. Any questions at this point? All good? Awesome. Don't suppose you've gotten your email that it's created yet? Okay. All right. Okay, good. All right.
And now for something completely different. It's touchscreen too. I forgot about that the first time I was doing this. So what is text analysis? Well, textual analysis is a way for researchers to gather information about how other human beings make sense of the world. Now you notice computation is not mentioned, and the reason is because human beings have been doing this for a very long time. However, today we're going to be talking about using computation in order to do text analysis. And just to give you a some idea of what's out there, there are some other tools. So Voyant is a popular one that people like to use for text analysis. Another one is called AntConc, and we'll actually have a screen later where it shows some keywords and context. And then, of course, we're talking about today, Jupyter and Voyant and AntConc are definitely, well, one, Voyant is more black box. It's good as a, I think, jumping off point if you're wanting to just get an idea of what you have really quickly. If you want a little more control, that's what the Jupyter Notebooks are for. You can make a lot more changes behind the scenes, doing things and changing the parameters and things like that. So AntConc also, it's more black box, but it's definitely really good for a really quick view of something. Like I said, the keywords and context is really helpful. That's what we use it for a lot. When we get something usually in the notebook that doesn't make sense, we'll then plug it into that just to see, okay, why am I getting this word that doesn't make any sense? It'll pop up. Mm-hmm.
But what they have left in are the speaker names.
Mm-hmm.
And so you can see there that word cloud that first comes up is their default corpora. Henry is really big because of the Henry, because Henry talks a lot, right? And that's actually a false frequency bit. So you can add it to the stop word list, but if you're just sort of trusting what Leonard is doing, like right off the bat, then you're sort of not really thinking through this. And David will talk about actually what we're using when we get to Hamlet and why we're using it.
So what is text analysis good for then? Well, talking about Hamlet, this is actually, the bar graph is actually an output from one of our notebooks, the histogram one. And you can see one of the most common words in Hamlet is Lord. So obviously it's an address, you know, good my Lord and all that. You can see in context how it's used, and you can see Hamlet, God, and all of that, words that are used around it. And then this is AntConc actually, and we can see the keywords in context. Well, what this also tells us is that there are some class issues in Hamlet, right? Because people are speaking up to somebody, my Lord. They're referencing them in that way, giving them that title. So this tells you that there are a lot of interactions between nobility and people that are not. So, oh yeah, I forgot. This next slide takes a little while to load because I used word clouds that have a really high resolution. So it'll look pretty when it comes up though. There we go. So this is actually an example of topic modeling. So each of these word clouds is actually a topic that was created using one of our notebooks. And the larger the word in the word cloud, the higher the weight of that word is in that topic. So you can see Hamlet, mother, father, that makes sense because this is definitely dealing with family issues in Hamlet. And in honor of Valentine's Day, we found the one where love was a highly weighted word in the topic. So you can see love, night. That might be something you'd want to look at further. And then, of course, this is pretty obvious, king, man, because again, the idea of succession, who's king, whether Claudius has the right and all that are also major parts of Hamlet. So text analysis algorithms are important to many fields as they interrogate reams of data and extract trends not parsable by a human reader. So things that might take years or even some people decades, depending on how much you have, can be done sometimes in minutes using computational methods with text analysis. Can be used on articles, manuscripts, monographs, poetry, letters, legal documents, social media, and we've used them on all of these things for different people. So, and people that have mixes of these things as part of their corpora as well. Can be used on really large collections. Like we've said, we've done 3 million tweets. We've done people that have hundreds of documents. It can also be used on small collections like one play, Hamlet. Some vocabulary. So stop words is a word you're going to hear a lot in text analysis. And that's just removing words like the, it, of, and that don't give any thematic meaning. Text cleaning is something that's important. One of the things we do there is lowercasing. Can somebody tell me why it's important to turn everything into a lowercase letter? Why do we not want to have capitalization? Anyone? You in the back, Tassie. Yes, yes, yes. Tassie.
Because if late comes at the beginning of a sentence and it comes in the middle of a sentence, I don't want capital L late to be differentiated from lowercase l late.
Yes. So what Tassie said, if you have a word that's capitalized at the beginning of a sentence, like lake, you don't want it to be different from lake that comes in the middle of a sentence with a lowercase l, and it will do that. It'll think they're two different words, and so it'll count them separately. So that's one element of text cleaning. It also removes punctuation, sometimes numbers and other things. And then topic modeling, which we'll talk about next week. And if you look at the slides, you can see there's latent Dirichlet allocation, latent semantic analysis, word vecs, which are also called word embeddings, and we'll talk more about those next week. Sentiment analysis does what it sounds like. It analyzes the emotions or opinions, evaluations, and sentiments of a given text. And so we'll be doing that in 2 weeks. So now Katie's going to come up and
All right. How many of you have seen word clouds before today? Great, awesome. Then you already have a decent idea of where we're going with this. So word clouds are a really great way to quickly let you parse word frequency. And it does this with both the font size and with the different colors used. And so different parts of different subsections based on frequency will show up as the same font size. Things that are most common are the biggest. Things that are roughly equally common will be the same color, the same size. And so, no, it's fine. Yeah, can you go back just for 1 second though? Or I could touch. They upgraded the wall to a touchscreen last year, and it's still a little new to me, sorry. And so this is a more traditional way to show your readers frequency. It communicates the same information, but it's much less easy to kind of immediately get a sense of the frequency of words in your corpus or your document. It's also a lot less interesting, and it's the kind of thing that if they're reading this in your dissertation, they're like, and they'll start flipping pages until there's no more tables. But a word cloud's a lot more interesting, and we'll communicate this for you. Okay. And so, as we said, we've mentioned text cleaning, and we're working here with Hamlet with a copy of the text that came from the Folger Shakespeare Library. And this is a version of it that has been cleaned. And I've got 2 versions up here. One has the stage directions and the speaker names included, as Tassie mentioned. And so if we ran analysis on this, we get hits for scene. We would get extra hits every time a character was mentioned. The version of the text that this analysis was run on is this one. So it's had all of that removed so that it's only what the characters are saying within the play. And then how many of you who in here is familiar with Hamlet? Excellent. That's not always the case. And so you're familiar. So basic plot, his father, the king, is murdered by his uncle, he being Hamlet. A lot of people become mad, or people think they're mad. Lots of bad things happen, and everybody dies. And this is reflected in the word cloud. But sorry if that was a spoiler alert. Spoiler alert! I just ruined Hamlet for everyone. Yeah, I don't like that play. But all of the excellent summary I simply provided, it's shown in this word cloud, right? So we've got mad and madness showing up in our word cloud. King is very common in the play, and so it's pretty big. David's already mentioned Lord is very common, and so it's the biggest one in the word cloud. We do have some people's names because they're mentioned quite a few times. Dead, not surprisingly, comes up. Yes, it's a bad idea. That would be different processes in text cleaning that would do lemmatizing or stemming, and that lets your analysis look at words that have the same root, the same stem, and counts them in the same. And so that's particularly helpful if you're working with non-English languages that have all those different forms. Max is also a medievalist, and so he knows exactly what I'm talking about. On lots of different words, and you can do text analysis on a variety of languages. There's support for quite a few at this point. All right. Another option is to make an Ngram word cloud. An Ngram is a set of words that appear directly next to each other in the text. And so most often if you hear people talk about bigrams or trigrams, groups of 2 or 3 words. And so this is a word cloud of bigrams within Hamlet. And keep in mind, we've already into the text cleaning. So this is taken out connectors like and. And so you'll see here words that would most likely have had and between them, but because this is the cleaned text, we can see that connection between them. So heaven and earth, but heaven and earth appears close to each other very often. There's a lot of fathers. We should do this on Father's Day next time. Actually, that's a bad idea because everyone dies. Farewell, Ophelia. Ophelia is one of the major characters. Bloody Dead. Maybe we should have done Romeo and Juliet. Sword and Swear. Second Husband. Adieu, adieu, goodbye, goodbye, which makes sense because again, everyone does. And so there are a lot of different things you can do with word clouds to communicate important things within your text, or like the topic modeling example David showed. So these are actually pretty versatile. And so what we're going to do now is make a word cloud drawn from Twitter data. And the Twitter data that's been pulled for this comes from tweets about the coronavirus, which has been, we try to do things that have been in the news recently. And so, I know you're set up, you're still waiting. And Max, are you gonna try and run it on your, okay, so we'll give it a go. And anyone who can't walk through it with us today, do it on your own. If you have questions, email us and we can talk you through it, all right? So in Firefox, in your notebooks, click on word frequencies. Oh, we did that already.
Oh, I'm sorry. I was behind.
Oh, yes. Yeah. Yeah. You'll see word frequencies. And then inside. Once you're in word frequencies, go to word clouds and then choose notebooks. There are 2 notebooks in there. One's for plain text, one is for Twitter, and we're going to work with the Twitter one today. Word cloud Twitter-Pi. Everyone set? All right, awesome. And so David's going to walk you through the notebook. This is a rough outline of what we'll be doing. There are a couple, no, we've got another one. Yeah, don't worry, we have a plan. Don't worry. There are certain parts where you'll make some modifications, or if you want to change parameters to make the word cloud have more or less words in it, change the DPI. And so those are in red, and those are the parts that David will point out to you in a bit more detail within the notebook. And as you said, there's lots of annotations, so these are great to come back to and read through in more detail about what each of the steps is doing to get a better sense of it. And if you have questions, or need help with stuff as we go through this.
Okay, so we are going to actually start with the word cloud Twitter one, and then after this, we're going to walk through this stacked area graph text one. So, but first to start, you can see all the annotation here, and to run the code, there's actually going to be, I'm going to show you 3 different ways to run it. So if you want, and you just want to run it all at once, and it'll run through every cell of code, just go up to cell right here, and you click run all. And I'm going to go ahead and do that so that the word cloud outputs at the bottom. And I'll try to remind you guys if you want to go through and do it a cell at a time to do that. But you can also do it this way, and it should run. So you can see it automatically brings you to the bottom of your word cloud here. And something you're going to notice, there's an asterisk in this little box off to the side. That means it is still computing. It's still processing information up above. And as it goes through and does some of this, and I'll go to the top, and we'll actually probably faster if I drag this. Okay. So we'll go to the top, and you can see it's replaced the asterisk with a 1. So it's going to count the number of times a cell block of code has been run. So if you're jumping around cells of code, those numbers are going to get changed. Every time you run something, it just adds another number to it. It just ups it by one more. So this first, and then the other two ways you can run cells are you can highlight it like I've done right here. You can see it's highlighted. You'll see the blue box. And you can actually just click on this button up here. That's the triangle pointing at a line. So a little, almost like a little arrowhead pointing at a line. That'll run just that highlighted cell. The other way is to highlight your cell and you hit Shift Return on your keyboard. Just Shift Return. And that's my favorite way when I'm doing it a cell at a time, because it'll just go through the annotation portion too, which the annotations are done in Markdown. So it'll just go right through it if you want to. So, but to go through this code a bit, if you look over here, I'm going to stop in more detail at the ones in red. So I'm going to go a little faster through the other ones. So this first block is just pointing to our Python environment in red so that you have all the packages you need to run our notebooks. And then the next one is actually pulling in Python packages. And as you can see up top, I have a lot of explanation about those packages and packages in general in Python and what they're for. The first place where you're going to really want to actually make changes is this block here, and it's where we set variables. So in Python, variable is something that where we're going to keep this name, and this, so file type is always going to refer to what we have saved after it. So now I'm saving the file type is JSON. So .json, it needs to be in quotes on this, okay? For Twitter data, it comes usually in two file types. .json is the one that comes straight from the Twitter API. So if you're pulling straight from their API, you're going to get a JSON file. So most other places you get it from, if they've kept it that way, it's going to be in JSON format. The other one we've run into is CSV. That is usually if you're getting your data from someplace else that has already pulled it and saved it, and they don't have the JSON format available anymore. And we've run into that a few times too. So that's why we only do those two file formats. So your file type, you're going to want to either have be .json or .csv, depending on your data. Single doc equals true. This basically is setting up something where if your data is in a single file, one file, so one JSON file, one CSV file, then you want that to be true. If it's in multiple files in a directory, you're going to set that to false with a capital F. So in Python, usually when you have common commands like this, like true, false, or none, the first letter's capitalized and the others are lowercase. So capital T, true, capital F, false, capital N, none. For NLTK stop and custom stop, these are our stop word lists. NLTK is a package. We're just using a built-in stop word list that they have, and we're saying we want to. And custom stop is if you have your own stop word list, usually a .text file where you've created something that is specific to your data, that you don't want to have to type in a big, long list later in your code of these words. You can just pull in a file. The stop language then is English. It's just saying we're using the English stop word list. And as Katie mentioned, there's lots of language options with NLTK. And you can go and look that up and see what they are. Encoding, we're saying that we want to, our data is in UTF-8, and so we want to read it in that encoding. If you know it's in a different one, you can change that there. Errors equal ignore is actually part of the encoding. So right now we're just going to ignore any encoding errors because at the moment I know I requested English. So if we get any errors, it's probably not going to be anything that's detrimental to our results. However, if you're using another language and you know you've got a lot and you want to make sure you get all of those in, then you're going to want to change that to none without quotes, as I talked about before. And then this stop words equals empty square brackets. That's just an empty list. And we're going to be appending or adding things to that list farther down in the code. But these, you're going to want to make changes here depending on your data, or you can just leave it the same for now as you're following along. And then we're setting our file paths now. And so this is where you might have some issues, but I've set it up so it should technically work. But again, we've had issues. So, and the reason it should work is because of this first home path equals os.environ. The OS package and using that environ function and having it set to home means it's going to automatically set that path to your home directory no matter what operating system you're on. So if you're on Windows, Mac, Linux, which is what Red is, I don't know if you mentioned that, Carbonate is a Linux system. So it should just go to that home directory. And so here now we're combining that path, you can see here with ospath.join, to where our text analysis master folder is and the data folder. So you always want your folder names and file names in quotes separated by commas. Data results is doing the same thing, except this is going to be where we save an output file later. So this is pointing to a folder that is part of our repo that will automatically save a PNG version of your word cloud there, so you can pull it, you can use it later for presentations. We now have an if-else statement. So this is where if our file type we set up there is CSV, then it's going to have this be the file path where it's pointing to our data in the CSV file. Else or otherwise, which that's the case here because we have it as JSON, it's going to point to the JSON folder and get our Twitter data as a JSON file. And then the next place you may want to make changes is here by the stop words, as I talked about before. We're pulling in the stopwords.words part here is the NLTK function, but we're adding our own words. So because I don't have a lot, I'm not going to pull in a whole nother file for this part because I only have 4 words I want to add to that list. And so that's going to add to that empty list up there. And then our custom stop, we do have a Twitter stop word list, which is going to remove things like RT for retweet because that comes up a lot. And some other things like that are common in tweets specifically. So because that's exactly it, because we look for it, so it's going to be in every single tweet. So all of a sudden it's going to take up the whole thing and you're going to be like, well, duh. Of course coronavirus is there because that's what that was my search parameter. So that's why I removed that. So now we're getting into some functions. This is the cleaning function. We talked about text cleaning before, so I'm not going to get into this, except to tell you that these are going to all be applied in our last cell. So functions don't do anything right now. So this isn't actually doing anything. It's just saving this function to be used later. So it's not actually going to be processing anything at the moment until we apply this function further down. This right here, we're unzipping files. So some of our GitHub has limits on how much you can upload. It's 25 megabytes. Some of our data is more than that, so we have to compress it and load it up there. This way it'll go through and unzip that file for you automatically. So it'll just look for it in that folder and unzip it, and you don't have to go through and do it. We have some more functions here. This one is to plot the word cloud. This is where we're reading in our file. Notice there's another if-else statement. So CSV, otherwise if it's JSON. Oh yeah, yeah. Yeah, we're going a little fast. And remember, there's annotations up above which also explain what's happening in the code. So if something is unclear in that, we can explain that too. So now we're drawing it if it's a single file. This is a function to draw it if it's from a directory. And then the last thing where we're going to actually go through a little bit more detail is here because we have more variables we want to set. So here, this is actually pointing to the document we're reading in. So we're reading in a file that has hashtags of the coronavirus dating from February 1st. It's actually February 7th. It's labeled 8th because that's the end date. So at midnight on the 8th, it stopped pulling. So, and then we're just adding our file type. So I've named it the same thing for both the CSV and the JSON. That way you can leave that name in there. And if you change the file type, it should still read in the other version of it. The output file then is what we're naming the word cloud that we produced. It's going to name it right now just a generic wordcloud.png. So you'll want to rename that to fit your data, whatever your word cloud is of later. The format, again, this is part of one of the requirements of one of the functions up above. And we're just saying the format is a PNG. So now it knows to look for that formatting. Width and height actually is going to determines what it is down here in the output of the notebook itself. And right now, and so you can mess with those numbers if you don't like what you see. You just change them higher, lower, depending on what you want. Text column index, that's going to be an important one right now, because that tells where it needs to look for the tweet content. So the JSON file automatically labels it as text, and then right after that is going to be the actual tweet itself, what was said in the tweet. And if you save it as a CSV, that's also usually the column header. Now, sometimes, and the CSV is where we usually see this change, because if somebody saved it over, sometimes they change it from text to like the word content, and then you'd want to change that from text to content. But again, always keep it in quotes, because it's looking for a string, a set of characters, and those quotes tell it that we're looking for a string. BGC is the background color, so you can see down a little bit that it's a white background. You can change that to black or gray or red if you want. And then CM is for color map, and there are different palettes you can choose from. This one's called Dark 2, so it's actually a palette of different colors that it has an option to color each word based on the frequency of that word. A note though, that if you rerun this, you're going to notice the colors change. That's because the algorithm doesn't necessarily start at the first color every time and assign it that way. So the colors change, but it should still be based on frequency.
One, you're pulling English tweets.
Yeah.
And you have to be aware that obviously, Twitter doesn't work really in China, right? Because of the bans that they have. So, and two, though there are probably people outside of China or in Hong Kong that are tweeting in Chinese, and that would change your results dramatically. The other thing is that I think as of Wednesday is no longer called the coronavirus. It's an absolute yeah.
Convi. Well, if you look, NCOV 2019. So, yeah, see, so if we look at our final output here, some of it actually, there's a couple more things. So again, I'm just gonna go back really quick through these last four. DPI is just the resolution. If you up it, it's gonna take longer to produce the word cloud because it's having to make it a lot prettier. Max word count is how many words can actually appear in the word cloud. We have it set to 500. You can adjust that depending on your needs. Minimum font means the smallest word is going to be a font of 12. Again, you can adjust as you need. And then the figure size is actually for your output. So the saved file, this is going to determine the size for that. And again, as you open it, you can determine if you like that. And then the nice thing is once you've run this all, you can just rerun this last cell over and over again, making those changes. So you don't have to start at the beginning. You can just start at that cell and keep doing it. So like we said, we go down here, you guys were talking about the names. So you can see that people are really concerned more about where this originated from, as opposed to where it has gone since. We also have SARS was also, you can see, very prominent. And we have, and one thing I thought this would be bigger would be quarantine, because I know that's been a big topic as well. But you can go through here then and pick out some things that either maybe surprised you or that you expected, but expected to be more prominent, things like that. So we are going to now move on to the stacked area graph, and this will go even faster because a lot of our code is repetitive. We reuse it, so I don't need to explain quite as much. Oh, so yeah, sorry, I need to go back to the.
I'm just going to click.
Okay. We go to text analysis master.
Tassie, we've got it. We've got a slideshow pointing to the.
So the stacked area graph shows word dispersion in space or time. So this example here you can see is actually of Hamlet as well, and we've chunked Hamlet for every 300 words. So it breaks Hamlet down 300 word chunks. So this is the first 300, second 300, third, and so on. And it's looking how many times the word Lord, King, Father, and Mother appear in each chunk. So you can kind of see word relationships over time, linearly in a book, and that kind of thing. So.
Yeah. Well, I was going to leave with you, but yeah. And so we're going to go back to the same part in the notebook, back to word frequencies. And so this time we're going to go into stacked area graphs and then notebooks again. So it's in that same word frequencies folder within text analysis master that the word clouds were in. Is it running on your desktop okay, Max? Awesome. Okay, great. All right. And so when you get into the notebooks, we're going to do the first one, stacked area graph text this time. And in this one it does. Yeah. All right. Has everyone found that notebook? All right, great. And David's going to talk you through that one again.
Okay, so we're going to go back to our okay. So our outline now for the stacked area, again, I'm going to focus more on the red and probably even less so than the last time though. So same things as before. We pointed to our environment up here, pulling in packages down here, setting our paths, file paths again. You can see there's fewer of them this time, which is nice. And then here, I'm not going to focus too long because we've already done the single doc, the stop words, the language, the encoding. Here, the text file, so this is telling, we're doing it up here instead of down below this time. And we're going to do hamlet.txt is the file we're trying to pull in. So it's going to ignore that if you set single doc to false because it's going to read in the whole directory. And then the other important one is chunk size. So this is going to, how many chunks you want to break it into. If you're reading in an entire directory, it's going to automatically just break it in by document. So each document will be its own chunk, but if you're reading in one file, then you need to, break that up a bit. So this number is going to depend on how big your data set is and how many words are in it, because you don't want your stacked area graph to be so long that it's unreadable or so short that it doesn't tell you anything. So you might need to play with that number a bit. And then we already did stop words. The free dictionary right here is it's an empty dictionary. And a dictionary basically is, it's kind of like a JSON. It's a bit simpler. It has a key and a value. So you're going to save something and it's going to have the key in there, which in this case is going to either be the chunk number or it's going to be the document name. And it's going to have a value, which is going to actually be the content of your chunk. So whether that's the 300 words or it's the entire document, that's going to be, the key is going to be one and the value is going to be the actual data content. And then the other really important thing is our interested words. So this is where we're looking for, we're saying, I want to see the count for Lord, King, Father, and Mother in each of these chunks. So for every chunk, I want to look at how many times these words appear so I can see the relationship throughout the entire text. And then we do, again, come down here and we can change our stop words if we want. And I remind you again, sorry, before I didn't do this, can either run all or again, shift return or highlight and hit the play button to actually get an output. And when you do this, this actually outputs an HTML file. So this is going to suddenly pop up in my browser here because this is actually an interactive, it's an interactive output. So you can see it just popped up. And I'm gonna, if I highlight over it, see it tells me that the word mother, I'm in chunk 22 and the frequency is 9. And you can see over here, if I want to see all of them at once on this, I can actually go up here and click on the 2 thing and then right there, and it'll, you can see as I go over, it's highlighting every word, telling me the word, what chunk it's in, and how many times it appears in that chunk. So, but for now, let's go back. We'll play with that more later and get some information out of it. So we have our stop words that we've added, and we have our own early modern stop word list that we made for this, for Shakespeare specifically, to get rid of. Oh, all right, she pulled that from there too. So it gets rid of like thee, thou, thy, all those types of things that don't normally appear. We have more functions. We have one that removes punctuation, another one for cleaning here. Again, we're reading in the text right here. If it's single doc, else. If it's not, if we're reading in a whole directory, it'll do something different, everything below that. So in Python, remember, indentation is important. That's why you have else, and it's indented. And then when I have here, every time you have a colon and I indent again, it's telling me that these lines are associated with this, and these lines are associated with that. So that is important in Python. Other languages it's not, but it is in Python. Now we're going to count our words. And then here is a long function that creates a data frame. A data frame is basically like a Excel file. It look very similar, but this is done. We're going to be using the Pandas package is a big one for using data frames. Here, if single doc is true, do the data frame. Else, we're going to do the data frame, but we're adding another element to that data frame. And that is, again, because we're going to be reading in a whole dictionary, so we want to add in our file names. So now we're down to where we actually have the output. And again, our output file, so this is what we're saving it as. So right now we're saving it as area stack hamlet.html. That's going to be saved in our output folder. So you're going to have an HTML file. If you double click it, it'll open in your browser. You can use it to actually embed it then in a website or whatever else you might like. Our color scheme is a little different since we're using a different package, the Plotly package. And so you're gonna, in the annotations, there's a link to some other available color options. But the set one's the only thing you're really gonna wanna change here. So right now that is our color palette we're using. It's called set one. So usually the package you're using will have something there when you go through all of its documentation, especially things like Plotly, or another one's Matplotlib. And then there's Bokeh and all of them. They're going to have something on their documentation site when you go to that package that tells you what some of the available colors are and how to access them and all that. So it just depends on what package you're using, where you're going to find that. If single doc is true, we're changing our X label, which is the bottom row, to chunk because it's a single doc, so we had to chunk it. Otherwise, we're going to label it document. So if you notice, and I'll show you again later, you're going to notice that it's labeled as chunk instead of document. The Y label is always going to be frequency, no matter if we're reading in a full directory or a single document. Our main title, you might want to change that if you're not doing Shakespeare's Hamlet. And then our Y range, so this is going to be the maximum range. And right now, it's set to about 42. That's because our max is actually going to be twice whatever the frequency is, the maximum frequency is of the words, of the words in our area graph. So that way it doesn't accidentally go over. And this way it's automatic. You don't have to run it, see that you have a number that's gone up past the top of your graph and have to figure out where it's at. It should. It just depends. I found that 1.5 sometimes it still went over because if you have other words that are also used a whole lot. Well, because you're changing words all the time, so it's hard to know based on by 2. Right, so it's looking for the word, it's looking for whatever word has the highest frequency. Yeah. It could, but if you have a second word that only had one less than that, one number less, then it's going to overshoot the top because you're stacking it. So basically, let's say, yeah, see, because like, so like Lord, well, Lord here, let's say, looks like it's in the, and this is where it's getting that double. You can see Lord is probably about 21, so that's why 42 is the max, because we doubled that. Whereas, let's say mother also happened to be 20 or something, and you did 1.5, it's gonna, that whole thing would have gone past the top of it. So you can play with that times 2. If you want 1.5, that's fine. I set it to 2 just because I had yet to run into ever going over with that number. So and then the angle equals 45 is actually the angle of the x-axis number. So you can see how they're slightly angled at the bottom at 45 degrees. This is really good if you have file names instead of numbers, because a lot of times if they're long, they run into each other. So this way you can adjust the angles to make it look a bit nicer for presentation and things like that. So, but like I said, we can now examine what does this tell us. Well, you notice here the word Lord is not used at all, but the word father is. Well, this happens to be the section where Hamlet talks to his father's ghosts. So he's talking to his father and using that term, but because they're equals, they don't refer to each other as Lord. And then they're familial, so they don't refer to each other in that term. And the same here, 24, you notice Lord's not used. Well, why? This is where Hamlet goes and talks to his mother and kills Polonius. So again, they're familial. They're not using those terms, not using Lord, but you notice mother skyrockets right there a bit. So,
there's literally almost no communication where you've got sort of the upper class and the lower class. And actually in this study, you can see that stylistically as well. And that when he's talking to Gertrude or Colliers or any of those folks, he's speaking in iambic pentameter. And when he's speaking to like Rosencrantz and Guildenstern, he speaks in prose. So like stylistically, Shakespeare also mimics that happening. And that's again where you can sort of see, you can see this more visually.
Yeah. Are there any questions about either of the notebooks, how to use them?
And we've got the links back up here where you can access the slide deck formatted for a typical size PC, so you have to look at it by this one. We've also got a list of past and current seminars. There's a YouTube playlist that has the recordings from previous seminars that we've offered at the same link, some of which are text analysis, so they might be of interest. So if you go to this short link, click on Services for Digital Humanities and Creative Activities, and you'll find a list of all the ones that are available for viewing. And then, of course, you can contact us at cyberdh@iu.edu if you have questions or want to go over these in more detail.
Saying that email address also, if you want to redirect somebody else to us, you can do that as well. Are there any online questions? There's nobody online? Okay. Yeah. All right.
Questions? Did anybody have any? Like,
Yeah.
were you able to walk? I would say that's a lot.
I'm more interested in use cases than knowing how to use the system itself.
Okay.
So that was
Okay.
Shown them, you know, the ways of going on, which can be magical. You know, like it's a really great way to get people up and running. And I think AMP too is a really great way to be like, hey, these are keywords and context, and they're color coded, right? And you just throw your stuff at it.
Yeah.
Well, and just lets you think about, like, it's really because you know, you start off with something like this, and you think the frequency is like one of the simplest things that you can do. And yet, once you really stop striking about one, like it actually makes you think, oh my god, I don't want to just throw this at a black box and see what it shows up. Yeah. So, yeah. Did you get confirmation?
At 12:50.
Okay. You had it by now. I wanted. I was gonna
Yeah.
check create additional accounts to make sure there's no.
So, and again, if you weren't able to follow along because of Carbonate approval issues, you can always get the slides and go back through it and try and do it again on your own if you want to. So. Okay, well, I'm going to end the recording then.